So today we will cover about how pointer arithmetic is used. What is the need of a pointer arithmetic? So already we have discussed about what is pointer, what is how we can initialize a pointer statically, and how we can print the address of a pointer. So if you see here, pointer is a variable which stores the address of a variable of a same data type. Same data type, what it indicates is, it indicates it can hold a address of only of same data type. If you have declared a pointer as integer, okay, then it will only holds the address of integer variables. In this case, I have used star ptr, which is a pointer of type integer. It can hold an address of either a variable I or j. Both are of integer type. And here, how we can initialize a pointer? Okay, so we can initialize a pointer by using a AND operator, where you will be giving the address of I, you will be assigning address of I to ptr. And when you want to print the content of pointer, what it does is it will print the content of a variable where which address is stored in this pointer. In this case, it will print the content of address which is I. So it will print the value of I. It is nothing but 10. Okay, so same thing, same pointer you can use it to, once your purpose is done with the pointer with the other variable I, you can use the same pointer and initialize that to address of j, which then pointer will point to j. So that you can always see here. So what we will do is we will just make sure that we'll first cover the basics once again, and then we'll jump to the pointer arithmetic. So if you see here, so you can always see what is the result here. See, what is the value of a star ptr? It is 10. What it is doing? It is nothing but I equal to 10. So since we have initialized pointer to address of I, when you use a star ptr, it will print the content of that address. Okay, content of that address is nothing but 10. So you can use either star ptr or I. Both will give the same value. If you want to update the value, you can always use star ptr equal to maybe 100, then it will update its value. Okay, you can just see that also. If you want to now update, okay, take consider star ptr is equal to 999. Okay, now you can check up, you can write updated value of ptr and I. Now we can run it. See what it is giving. So earlier just we have assigned I equal to 10, and we have assigned the address of I to ptr, and we have printed value of pointer. So both will give us the same value 10 10. And what you are doing, you are using a pointer. Okay, star ptr equal to, you are storing, you are updating the value to 99. Then it will print I is also is updated with the value 99. And or And what you need to do is you need to check again with the if you want to print the address. Okay, so you can print address using percentage p. So if you see here, star ptr, and ptr will store the address, and address of j also you can print using ampersand of j. If you compare both, see both are same because you are assigned a pointer ptr to address of j. So this is how you need to understand what is a pointer, what it stores. Pointer stores address, and you can always use that pointer to modify the value, modify the content of it, or you can increment that. If you are using an array, then you can increment that, and you can use a pointer to increment the array index. You can use pointer and array interchangeably, that we'll cover in next session. So coming to, so this is how you need to understand. This is a pointer initialization you are doing, and you can always update the value of a variable whose address is stored in the pointer using that pointer itself. This we have covered here. And you can print address of a pointer using ptr here. Okay, yeah. So coming to next, okay, so there is a concept called pointer arithmetic. What is pointer arithmetic? Pointer arithmetic is nothing but based on the size of the variable, okay, it will increment pointer by that many bytes. Suppose you can take integer character is a size of a character is 1 byte. So always when you are having a character pointer, it will increment by 1. When you are having a short pointer is 2. So when you are doing pointer, like here what you are given, we have taken a character c and cptr, which is a pointer of type character, and short is s, and sptr is a pointer of type short. So when you do sptr plus plus, it will increment by 2 bytes. When you increment cptr, it will increment by 1 byte because the size of a character is 1 byte. If you take integer, if it is a 4 byte, okay, size of integer is 4 byte. If it is a 32-bit machine, then what it does is it will increment by 4 bytes. IPTR plus plus, it will increment by 4 bytes, and double will increment by 8 bytes. Let us see here. So what we are doing here, CPTR equal to and % of C. That is nothing but we are doing a pointer initialization. What pointer can store? Pointer can only store address of same data type. That is why we have used character and character pointer here, short and short pointer here, integer and integer pointer here, double and double pointer, because we need to have a same variable, same data type as that of a variable. Okay, here we are doing pointer initialization. Okay, we are initializing IPTR to ampersand of I, DPTR to ampersand of D, and what we are doing here, we are first printing the address of all pointers. Okay, and then what we are doing, we are incrementing all those pointers by 1 1. Okay, plus plus, basically it will increment by 1. But when you see its pointer value, you will get to know that you will see that character pointer will be incremented by 1 byte, short is incremented by 2 bytes, integer incremented by 4 bytes, double is incremented by 8 bytes. Let us run that. Okay, see here. So if you take here character pointer, when you do C++, okay, CPTR plus plus, it is incremented by 1, 7 9 to 7a. Okay, it is incremented by 1 byte. And if you take a short pointer, it is 7A to AC. It is nothing but 2 bytes. When you see IPTR, it is nothing but 7C to 80. It is nothing but 4 bytes. C is 12, 80 is 16. Like 12, 16 minus 12 is 4. So it is increment by 4 bytes. Integer. If you see double, 80 and 88. So it is increment by 8 bytes. So this is a concept of a arithmetic pointer. Okay. Just you will increment by 1, but it increments the address by its data type size. Okay, no need to increment. For example, you are using a integer, you should not increment that address by 4 bytes. Okay, you should only use a plus plus pointer. Internally it will take care of that to make sure that when it goes to access the next variable, it will increment by its size of that variable. In case of character it is 1 byte, in case of short it is 2 bytes, in case of integer it is 4 bytes if it is a 32-bit architecture, 8 byte if it is a 64-bit architecture, and double is of 8 byte. Okay, that is what we are concluding here. Okay, you can always see. And then one more concept I want to cover here is about what is the size of a pointer. Okay, what is the size of a character pointer, what is size of a short pointer, what is size of a integer pointer, what is size of a double pointer. Okay, so that is why what we have done here is we have used again here a size of CPTR, this address, and you can see what is the size of that pointer. Okay, okay, see here what we are doing. Size of a CPTR is 8, size of SPTR is also 8, size of IPTR is also 8, and size of double PTR is also 8. Why it is 8? Because pointer size is depending on its architecture. Okay, if it is a 64-bit architecture it is 8 bytes, if it is a 32-bit architecture it's a 4 bytes, irrespective of whether the pointer is a character pointer, integer pointer, float pointer, double pointer, or a structure pointer. That is where the benefit of pointer lies. Okay, always it will be 8 bytes. So if you take a structure, okay, structure will have the size of a structure will be size of all its individual, maybe like if it is have a 10 elements, 10 fields of 4 bytes each, then the size of a structure will be 40 bytes. Okay, but if you just assign a pointer to that structure, pointer is 8 bytes. Okay, so why it is 8 bytes? Because what is pointer? Pointer is a address. Address is nothing but a integer. Okay. So that is where pointer size will be same for all pointers, whether it is a character, short, integer, double, or it's a function pointer, or it's a like other pointers. Okay, structure pointer, all will be of same size. So what we'll do is we'll cover in a next session about what is the similarities and correlation with pointers and arrays.